Quadratic equations are going to be of the form that are similar to y is equal to x squared. This typically grows faster than linear functions, except from, say, 0 to 1 or negative 1 to 0. It's a little bit slower because when you square terms that are less than 1, like 1/2, you get 1/4, which is less than 1/2. So it goes slower. But it is always positive. So a linear function, when you graph it, for instance, you have the positive, but then it starts turning negative when x is negative. Let's say y is equal to x right there. Now when we do y is equal to x squared, we always have positive values, so it just follows a shape like that. It has a sort of axis of symmetry. For y is equal to x squared, this axis of symmetry is just the y-axis. If we have some other quadratic, let's say x squared plus x, now it shifts to the vertex. Well, it's always at the vertex, but to find this, we say x is equal to minus b over 2a, which for this example is just minus 1 over 2 times 1, which is just minus 1/2. And if we want to find where that vertex is, we just plug that value in to our function. And this would give us 1/4 . Let me just scroll down a little bit. 1/4 minus 1/2, which would be minus 1/4. And so our vertex would be centered at, the parabola would be centered at negative 1/2, negative 1/4. And that's where the parabola would start, and it would just follow that same kind of shape. Typically when you work with quadratics, you want to find where it equals 0, these zeros, where it crosses the x-axis. These are also known as roots. I'm just going to write zeros, roots. It's usually the subject of interest for quadratic equations. So usually books will have it written like this, and what you do is you set that equal to 0, and then you just solve for x, which I'm going to do right now. So we have ax squared plus bx plus c is equal to 0. We can move the constant to the other side, divide out the a, and now we do a process called completing the square. So when you complete the square, you take the b over a term for the x coefficient, you multiply that by 1/2 and you square it, and that's b over 2a squared, which would be b squared over 4a squared, and you add that to both sides, which is basically adding 0 because we're adding to both sides. Now, because this process is called completing the square, the left-hand side is now a perfect square with the b over 2a. And the right-hand side, we're going to combine these fractions by multiplying this right fraction by 1, or 4a over 4a. And that gives us I could write it either way, but I like doing it like this. Now you just take the square root, and this is plus or minus because we want both solutions. And the square root of 4a squared is this 2a. And now we can just subtract the constant again, and keep in mind that these two have the same denominators, so we can just combine that easy into a fraction. Typically it's written like this: a minus b plus or minus b squared minus 4ac over 2a. And those are the roots of the polynomial. Sometimes this doesn't have a nice solution, but sometimes it does. This b squared minus 4ac is known as the discriminant. And it determines how many times it crosses this x-axis. If b squared minus 4ac is greater than 0, there's 2 real roots. If it's equal to 0, then there is 1 root. That means it has a double root that is the same number. And if it's less than 0, it has no real solutions, but it will have complex solutions. And these are of the form a plus bi, where I is equal to the square root of -1. Sometimes the quadratic equation is overkill. It will give the right answer, but sometimes there's just easier methods. One common method is just to factor it. I'm not going to spend a lot of time with factoring, but it's basically, when I was in school, I learned this diamond method. So you have 2 numbers on the top, which is a times c, and then the bottom is b. So you have this a times c term. I'll just write it down here again. 1 times 6, and then the b is -5. So we want 2 numbers that multiply to 6 and add to -5. It's kind of like a little riddle, a little puzzle, but if you just think about it, it's just x minus 2 and -3, because 2 negatives make a positive, and so that just makes x minus 2 and x minus 3 is equal to 0. or x is equal to 2, or x is equal to 3, and those are the roots of that polynomial. I think my pen might need more batteries. A little more complicated example could be like 2x squared plus 7x plus 3 is equal to 0. So same thing, we have our 2 times 3, and that becomes 6, and then they add up to 7. And there's really only two numbers that do that, so you want to multiply to 6 and add up to 7. That's just 6 and 1. So this one is a little different, so we're going to do 2x squared, and then the 7 is going to be split in between 6x and 1x. And I mean, we could just write that as just x, but I'm just going to write it like that. So you do that, and now you can factor by grouping. So this term and this term. So you do, that's got a 2x times x plus 3 plus 1 times x plus 3. And with factor by grouping, we can just do 2x plus 1 times x plus 3. And if you're curious, you can just FOIL it out. So that's 2x squared plus 6x plus x plus 3. It checks out. And if you wanted to solve for what x would be when it crosses, say, the x-axis, it would be x is equal to -3, or 2x plus 1 is equal to 0, or x is equal to -1/2. And that's basically quadratics for you. Thank you for watching.